All right, so horizontal curves. Chapter 24 in the book. I'm not going to assign any homework out of the book this time around. Formulas and stuff that you want to reference for this chapter are in. You can find them in chapter 24. You'll also find them in this PowerPoint. So horizontal curves. Those are curves that are basically found on any roads that we drive. There's vertical curve component to those roads too, but anytime you have two straight tangents, if you're driving a car, if you were driving on straight lines, you'd go right off the road because it was straight lines. So they make a transition with a curve, essentially, so you can drive through that, down that road without actually going off the road. So the first type of curve is a simple curve. So it's basically a circular arc connected by two tangents. And that's mostly what we're going to deal with in this class, is a simple curve. The next kind of curve is a compound curve. So it's where you have two or more curves basically that come together with different radius and a tangent on one end or the other. So there's a tangent on each end, and then the curves connect. Horizontal curve, the broken back curve. This is a curve where it has a short tangent segment of about 100 feet or less that connects two circular curves. So that's called a broken back curve. We will have, in some of those problems, there is actually a broken back curve in some of the homework problems. I think it might have been number 6 or 7. That's an example of a broken back curve.
7.
It's 7. There's a reverse curve. That's two circular arcs tangent to one another with their centers on opposite sides of a common tangent. Okay? So this is a common tangent here. They share the same tangent line. So that's a reverse curve. We'll talk about the tangents and different stuff like that here in a second, what the nomenclature is for a curve. All right, there's spiral curves. So that's a transition curve between a tangent and a simple curve, in which the radius decreases uniformly from the tangent to the curve. So this is typically used in railroad systems. The reason that is because if we were running a train into this curve and it was a simple curve, there would be no transition to the curve, essentially. That spiral is your transition. So that's where you'll see spiral curves. You'll see them on some highways. They'll have spiral curves. So most highways nowadays actually have spiral curves, but that's what that's for, is they make a smooth transition into the actual circular curve. The degree of curvature is the angle formed between the radius point and a 100-foot section of arc. A 100-foot section of arc. So that's a very important concept. We are going to deal with arc definition curves. That's the math that we're going to be doing. It's arc definition. That's highway curves. Chord definition curves are railroad curves. Okay? So that's 100 feet on the curve, essentially, is what that's saying. 100 feet of the arc. It's not 100 feet on the chord line. The chord line would basically be connecting the PC to the PT. And we'll get to that. So the point of curvature to the point of tangency. That would be the chord. So that would say if it was 100 feet, it would actually, that chord would be shorter than the actual arc distance, right? So the degree of curve is defined by 100 feet of arc. 100 feet along the arc, I guess, of the curve. So some definitions here. Okay, so I have a diagram that'll show all this here in a second. So the PC, when you see PC, that means point of curvature. So that's where the curve is beginning. Okay, that PC is where the curve is beginning. The PI is the point of intersection of the two tangents of the curve. Okay? The PT is the point of tangency. That's where the curve is ending. So we have the PC where the curve is beginning, the PT, the point of tangency, where it's ending. T is the tangent distance. So anytime you see in a formula asking for T, it's the distance of the tangent. TB is the tangent bearing. R typically is the radius of that curve. RP is noted as the radius point, so that's the point that is the center part of that curve, I guess. The center point of that curve, or arc. And then LC is the long chord. So the long chord basically connects the point of curvature, the PC, to the PT, the point of tangency. The distance between those, that straight line distance between those, is called the long chord. The chord is a segmented chord of a certain distance we want to go. Say we want to go 150 feet along the curve. What is the chord that makes up that 150 foot arc distance? What is the chord that connects that? That would be like a subchord, I guess. The POC is a point on the curve. A POT is a point on the tangent. The external, the mid distance, I'll explain those when we get to the actual curve itself. I can jump here quick. This is the external distance, so it's from where the curve hits, basically the perpendicular to the mid or the PI. So it's perpendicular distance from the curve to the PI. That's the external distance. The middle ordinate, the M, stands for middle ordinate, is the distance from the long chord to the curve on a straight intersection to the PI. So that's the middle ordinate, that M. What else do we have here? Degree of curve, we already talked about that. That's the distance subtended by 100 feet of arc, or that would be the angle, 100 feet of arc on the curve. So what it's showing here, it's normally set by D. So this would be 100 feet from here to here. The intersecting angle, which is also known as the delta, that's this. That's the intersecting angle, which is also this. So this angle is equal to this angle. Okay? And then the length of arc on the curve is L. So L is along the arc. That's the length of arc between the PC to the PT. Any questions so far?
Clear as mud.
Clear as mud.
I got a
Okay.
question. So
Yes.
the PC and the PT, is that just depending on which way you're looking at the curve?
Absolutely. So the PC and the PT can be used interchangeably. It just depends on the travel, right? So if we look at this example, my back tangent is where I am. My forward tangent is where I'm going. Think of it that way, okay? So I'm sitting here, I'm going to travel through the curve like this. That's my back tangent. What's behind me is the back tangent. What's ahead of me is the forward tangent. So what this is telling me, the way that they have this labeled, is the stationing in this curve, or the direction of this curve, is going from left to right because of the way it's labeled right now, back tangent, forward tangent. So the stationing would be like 0 plus 0, 0 on this, on the left-hand side where the back tangent is, and going through, I would be adding up in my stationing, going through the forward curve. Hopefully that makes sense. All right, so here are the formulas for solving a lot of the information that we're going to be trying to figure out in the curve, to be able to define the curve, so that way we can get to that step where we're figuring out deflection angles. Now these formulas they're not great. I was trying to find a better example of how they're written out. This is an example from when Rick had these slides, and I was online yesterday trying to find something better because I just don't like these. They're not super clear on how they're written. I'll try to clarify them when we do a couple examples today for these formulas. What I'm going to probably end up doing is making my own document to update these. So they have a few formulas on here that we're going to end up changing around when we go to find things. Just remember that we're never going to really use this formula here, the thing to find radius, because that's for a chord definition, which is a railroad curve. We don't work with railroad curves. We work with arc definition curves. So you'll see these as we go through a couple examples. And if you guys want to print the slides, you'll have these. They also have versions of these in the book. Okay? So horizontal curve stationing. In route surveying, a system called stationing is used to specify the relative position of any point along a reference line. You typically start at 0 and you don't go negative typically. You stay in the positive. So a station is displayed with typically in feet, and it's displayed like 0 plus 0, 0 or 1 plus 0, 0. And stations are typically 100 feet apart. So when they're displayed, I would have 0 plus 0, 0, 1 plus 0, 0, which if I was trying to figure out what the distance was between those two stations, it'd be 100 feet. Or 1 plus 0, 0, what's the distance between 1 plus 0, 0 and 5 plus 0, 0? It would be 400 feet. So it's pretty simple to work within those means. So the term full station is applied to each of these points set at 100-foot increments. So that full station is every 100 feet. Now there will be examples when on the homework, I think I have you figure it out at half stations. So when I say half stations, I mean 50 feet. Okay? Quarter stations would be 25 feet. So a point along the center line of the road stated as 1700, or 17 plus 00 would be 1700 feet from the starting point. Okay? So here's an example. So if I was 84.90 feet beyond station 17 plus 00, I would show my station as 17 plus 84.90. That's what my station would be. Oh, my mouse is acting really weird right now. So I'm giving you the answer here too. So what's the distance between these two stations? 3 plus 15.75 and station 8 plus 03.50. If you subtracted those two stations, it's going to give you 487.75. That's if I did my math right.
You did.
Okay, good. Thanks. All right, so here is how we find the PC or PT stations. These two formulas right here. So the PC station is, well, the PI station, if I'm trying to find the PI station, it's the PC plus the tangent. Well, if I'm trying to find the PC, it's basically the tangent minus the PI. And then also, if I'm trying to find the PT is the PC plus L. Now, why can't I just add the tangent to the PI station to get the PT? It's different. We can't do that. You can do that in vertical curves, but you can't do that in horizontal curves. So when you're trying to find any of these, use these formulas or a version of these formulas to find the PC or PT. Okay. All right. So let's put some of this to work, and it'll all start making sense as we put some of it to work here. All right. So let's do an example problem here. All right. So typically I always start with what I know. So my known, well, I'm going to have to adjust the camera here. Hang on for a second. There we go. All right. The known that we know from our problem given to us, the PI station is 14 plus 0.00. The I that they give us is 9 degrees, 00 minutes, 00 seconds, and the R is 650.00. 650 feet is the radius. So I stands for what again? The intersection angle. All right, so let's write down what we need to find. So what we need to find, I want to find L. I want to find the length of curve. I want to find the long chord, the delta, or the degree of curve, the middle ordinate, the external distance, the tangent, and then the PC and the PT. Okay, those are the things that we are going to find based off of the information that was given, the stuff we know. Okay, so we'll use that list of formulas that I have in the PowerPoint. Alright, so the first one, they give us R. So if I look at our list of formulas, quick, let me get back to that. Open this up again. So this list of formulas, if I look at our list of formulas, if I look at what we have the PI station, we have I, and we have R. So if I look at that list of formulas, what would be the most logical thing to find first?
L?
We don't have, yeah, we do have I, so we could find the long chord, but I'm thinking let's find D because it has one variable that we have to use, right? And that's the radius. So let's find D. All right, so formula there is D equals 5729.58, which is a constant, divided by R. Okay? That's the formula. So if I take the 5729.58, divide it by my R, which is 650.00, what do I get for D? Now, D is in degrees. So the answer you get, you're going to have to convert it from decimal degrees to degrees, minutes, and seconds. Okay? So whenever someone gets that, give it a shout. 8 degrees, 43 minutes, 48 minutes, 53 seconds. Okay? So I just solved for D. Can anybody concur that answer?
Yes.
Okay. So D is 8 degrees, 48 minutes, 53 seconds. Okay? So we solved one of them so far. Alright, so let's take a look at our list of formulas again and see what else we can find. So we just found D, and we have I, right? So we could find L, the length of curve. So let's do that one next. So L is equal to 100 D times I. Okay? So that's 100. Make sure you turn D into decimal degrees when you do the calculation, times I. So
I is 9 degrees.
9 degrees. Okay? So what is L then? L is in feet now. Shoot again. 10.21. That's a really small L. This is a short curve.
I got one or two.
Okay. Okay, so it's 102? 102.10. Okay. Okay, so L is 102.10. 102.10. 8. Okay. All right, let's look back at our formulas again and see what else we can solve. All right, so we can figure out LC, or we could figure out the tangent. We have R and I. Let's do the tangent. So, tangent equals the radius times tangent of 1/2 I. Okay? So if I put the radius in there at 650, tangent of 1/2 of I is 9 degrees. What is the tangent? And remember, this is tangent length, not tangent bearing. 51.16. That is in feet. So our tangent is 51.16 feet. Okay? Next.
It's our first one, man.
We can figure out LC if you guys want to figure out LC. So LC equals 2R sine of I over 2. Okay? So it's 2 times 650 times the sine of I over 2. So 9 degrees 00 minutes 00 seconds over 2. So LC equals what? $102.00. Yep, that works. Okay, so that's our LC, so we'll transfer it up here. 102.00 feet. That's the long chord. Okay, so that's the distance it is from the PC to the PT on a straight line. Okay, so this is from the PC to the PT on a straight line. This distance here is along the arc, the distance of the curve from the PC to the PT along the arc. So it's a pretty flat curve. It's only a tenth longer on the arc. All right, what's the next one we want to solve for? Should we shoot for, yeah, let's do E. So there's 3 different equations you can use for E, but we're going to use this one. tangent times the tangent of 1 or I over 4. Okay, or I divided by 4. So T is our 51.16 times tangent of I 9 degrees 00 minutes 00 seconds over 4. And that's going to equal something that you guys tell me. Two point zero one. 2.01. Okay, so E is the distance from the intersecting angle, the PI, point of intersection, to the middle of the curve.
The curve?
Right? Let's take a look.
It's basically the middle of the long chord, midpoint.
Goes to the curve.
Oh, it's M.
M is the middle ordinate. So E is the distance from the PI to the midpoint of the curve. That's the external distance. Okay? So we just solve for E. Let's solve for M then, the middle ordinate. So M equals E cosine of I over 2. Okay? So we figured out M, so that's 2.01. Well, I forgot to write it up here. That's feet. 2.01 cosine of I, 9 degrees 00 minutes 00 seconds, over 2. What do we get there? 2.00. That's the distance from the middle of the arc, or the midpoint on the arc, to the chord. Okay, so that would be like the longest distance between the chord and the middle, or the chord and the length of curve, or the curve itself. Okay, so we figured out E, which was, oh sorry, I wrote that in the wrong one. It's 200. E was 2.01. So we just figured out M. I wrote that in the wrong spot. Let's figure out the PC and the PT now. So the PC, we know is PC is equal to the PI minus T. Okay, so the PI, which was given to us, the top is 14 plus 00. 14 plus 00 minus, don't confuse that plus with something that you have to do in the problem. 14 plus 00 minus T. T was 51.16. Okay, so what does that come out to be? 13 plus 48.84. So that's our PC station. Okay, let's figure out the PT station then. PT is equal to the PC plus L. Okay, so the PC we just figured out. It's 13 plus 48.84 plus L is 102.10. 102.10. So our PT station then is going to be 14 plus 50.9 PT station. So we basically just solved all the information we need to know for the horizontal curve. So I'll add these up here. So my PC was 13 plus 48.84, and my PT 14 plus 50.94. Okay? So we just solved all this information for this vertical curve. So we were given 3 items and we solved 9 items, 8 items from the 3 things that were given to us. Okay? Should we try another sample problem?
I had a question on E.
Mm-hmm.
You said there's 3 equations? Or is that supposed to be 2?
That might be 2. There's 3 equations there. Just this. That's why I don't like this sheet. This formula sheet. That's why I go with the ones that I know. I have to redo this formula sheet because I don't like how it's displayed on here. It almost looks like you're taking and all these things are together in one formula. Is what it looks like. So that's why I don't like that formula. So we'll just run by the ones I give you. Okay. Run with the ones that we just did as an example. Now we might have to do some, we might get a problem where we have to do substitution with some of these, where we might be given, we have to find E, but all we're given is I and M for the problem, for the known stuff, and we might have to do substitution to find E. Okay, so be ready, because I know there's problems that you guys are going to have to do substitution on. They're not as straightforward as this first problem that I just did. How do I know that? Because I had to do it. So we'll try doing a couple more example problems, something that we know some different stuff with. So the known here, I'll give us something different here, and we'll have to figure out some other stuff. So there might be, in those examples, the next couple examples, there might be something where we have to do some substitution here. So, all right, start from scratch.
Yay.
All right. So let's take a look at the next one. All right, so we are given, so we know we're given the radius, and it's 800 feet. Tangent is 651.50 feet. And the PC is 51 plus 26.89. That's the station. Okay? What should we solve for first? I think we should do D, is what I think, because we were given the radius, and that's the easiest one to find first. So let's find D again. D is equal to 5729.58 divided by the radius, 800. So what is D? In degrees, not decimal degrees.
0 degrees,
0 degrees,
39 minutes,
39 minutes,
43.11 seconds.
43 seconds.
That's 7 degrees, 9 minutes.
Oh, man.
Oh, man. All right, wrong answer here. So what was the right one?
You are a no-go at this station.
Yeah. 7 degrees?
7 degrees, 9 minutes, 43 seconds.
Simple decision.
43 seconds?
Yes.
43 seconds.
43.
43 seconds. Okay, so let's write over here all the things that we have to find. I forgot to do that.
I did 579 instead of 5.
So we need to find D I L LC. We found D M E, and then the PI and the PT. Okay, so those are the things we're going to need to find on this one. D we already found, so that was 07 degrees, 09 minutes, and 43 seconds. Okay, we found D already. All right, so should we go off and let's see here.
No.
What's the next one that we can do? We need to find I. All right, so here's one of those ones that we might have to do some substitution on. Huh? So let's look at the formula for I. Okay, so we have D and R and T. Okay, so I have R and T in this first example here. I could technically do that, right? So does anybody know what the substitution would be for that one? So T equals, if I'm trying to find I, R tangent of 1/2 I, or I divided by 2. I know what it should be, and I know how to get there, but I want someone to tell me how to get there. So can I display it like this? So I equals,
It would be I equals R tangent half times T.
will that work too? Oh shoot, sorry, can't see it. Okay, so would that work?
Yes.
That would be the substitution for taking I out and putting T in. Okay? So this might be very similar to one of the problems that you have in your packet.
Would it be T over R tan 1/2 equals I?
It's up there. Board.
You're getting close.
Okay, so the whole thing is actually times by 2. Alright? So the inverse tangent times T over R, and then the whole thing times 2. So I equals inverse tangent of T, 651.50 over R, 800, double bracket times 2. Now this is an angle. It's I, right? I is an angle, so it's given. When you get the answer, it's going to be in decimal degrees. 19 minutes, 01 seconds. That's I. Okay, and we have someone that concurred with that. So 78 degrees, 19 minutes, 01 seconds. Okay, based on your math background, you should be able to do substitution. Okay? Alright, so now that we have I, what else can we solve for? Long chord? LC, look at that. Yep, we can do this one right here. So let's solve for LC. Okay, so LC equals 2R sine of I divided by 2. 2, what's R? It's 800. I don't want that bracket there. 800 sine of I over 2. And I we just figured out was 78 degrees, 19 minutes, 01 seconds. So LC equals 1,010.35 feet.
Yep.
.35 feet. 1,010.35 feet. All right. What do we want to solve for next?
L.
L. Let's solve for L. So L is 100 over D, right? Times I. So 100 D, we figured out, was 07 degrees, 09 minutes, 43 seconds, times I, which we just figured out, 78 degrees, 19 minutes, 01 seconds. So L equals you say that soft because you got the last two wrong, or what?
No, I only got one wrong. 1,093.52. Yeah. Say what you check.
1,093.52.
Sam seconds it?
0.52.
Well, he's been wrong too.
Yeah.
Okay, so L is 1,093.52. Now here's a check. Okay, so we know that the long chord connects the PC and PT in a straight line, right?
Yes. L should always be.
So the LC should always be less than the L, or the L should be more than LC. So, because the length of curve is on the curve. So there's a check right there. We just noticed, if it's the opposite, then we got something wrong in our calculations. So, good check. All right, what do we want to solve for next? E? Okay. E equals T times the tangent of I divided by 4. So tangent, we figured out, is here. It's already given to us. So it's 651.50 times tangent of I divided by 4. So I was 78 degrees, 19 minutes, 01 seconds, divided by 4. So what is E? .72. 231.72 is E. Okay. I guess one of the last things we need to do is solve for M. So let's do M. M equals E cosine of I divided by 2. So E we just figured out. So what is M? Oh, I did divide by 4. Sorry, that's supposed to be 2. I'm still solving for E.
.68.
179.68 feet. So 179.68 feet. All right, so let's figure out our PI first. Okay, because we were given the PC. We got to figure out our PI and PT yet. So the PI is equal to the PC plus T. So the PI is PC plus T. So the PC was 51 plus 26.89 plus tangent, which we were given at 651.50. So the PI equals what? 57 plus 78.39. So that's our PI. 57 plus 78.39. Alright, so let's solve for our PT then. So the PT is equal to the PC plus L. So our PT is equal to PC, which we were given, 51.2689. 51 plus 26.89 plus L, 1093.52. 1093.52. PT equals what? 62 plus 20.41. Okay, so that's our PT station. 62 plus 20.41. Alright, so notice how I'm sort of laying out these problems. The reason I lay them out like this, where I write what I'm finding, is because I'm hoping that when you guys do your homework, you do the same thing and you're nice to me. Because I don't want to hunt and peck through formulas for the answer. So if you can give me the answers just like I just structured this homework, all your work is done over here, and then you have an area just for your things I want you to find. It's going to make it a lot quicker for me to grade it, which would be fantastic if you could do that. Yeah, I'm not that mean. I'm not that If they're not here, I'm still going to look for them over here. I'm not going to mark you off for not having them here, but be nice to me and put them over here if you could. That'd be great. Shall we do one more? Right. What was that? We get tough. All these are not that tough.
On stationing, you never put like a foot symbol on it?
No. Most plan sets will tell you what the units are. So if it's meters or feet. Now, meters, if we were in meters, it would be labeled like 1 plus 0, 0, 0. That'd be meters. Because this then would be 1,000 meters. So they put the plus out ahead of it. Because we're in feet, we can do 1 plus 0, 0. So that's 100 feet. So, just a little bit different. But we'll always work in feet, so don't worry about the meters thing. I'm not going to throw a zinger at you and have you work in meters. Shall we do one more? Might as well. Why not, right? Alright, so I'll give you our known again. And our known, we know D equals 1 degree, 0, 0 minutes, 0, 0 seconds. T equals 500.00. And then they give us the PT. Okay, and that equals 17 plus 50.00. Okay, then we want to find our L, the LC, the M, the E, They give us T and D. We need to find I and R, the PC and the PT. Okay. There should be 8 of them there. That's what it looks like. Okay, so where shall we start first? PI. Oh, we found PT already. That was easy. They gave it to us. Alright, so where shall we start?
Find R.
Let's find R. That's the easy one, right? So R equals 5729.58 divided by D. We just switched the formula, right? We substituted R and D. They flipped. So 5729.58 divided by D. 1 degree, 00 minutes, 00 seconds. So what's R? 5729.58. So 5,729.58 is R. That was a simple one. What shall we find next? What do you want to find? I? Okay. Well, we know from our previous one that we already did some substitution on that we can do I, and we can show it the same way we did on our previous one. If we do some substitution and the inverse tangent of T over R times 2. Okay? T is 500 over R, which is 5729.58, all times 2. So I equals what? 29 seconds. Okay, so that's I. That's a pretty tight I. It's a small one. It's a short curve. Okay, so that's I. Figure it out. Okay, what next? LC, you want to find? LC equals what? How do we find LC? 2R sine of I divided by 2. So 2 times R. R was 5729.58 times sine of I over 2. I was 09 degrees, 58 minutes, 29 seconds over 2. Okay? So what are we getting there? 996.21. 996.21. That's in feet. 996.21. Okay. Shall we go and find L next, or what should we do? Let's find L. So L equals 100 over D times I. D was 1 degree, 00 minutes, 00 seconds, times I, which was 09 degrees, 58 minutes, 29 seconds. So what does L equal? 997.47. Okay. 997.47. If we do our check again here, L is a larger number than LC. So there's our check that we most likely computed it the correct way. Which one do you want to find next, M or E? Okay. E equals T tangent of I over 4. Okay. So T is 500 times tangent of I, 09 degrees, 58 minutes, 29 seconds, over 4. So E is what? 21.78 feet. 21.78 feet. Have M to solve yet? M is E cosine of I over 2. So E we know is 21.78. Cosine of I, 09 degrees, 58 minutes, 29 seconds, divided by 2. What is M? 21.70 feet. Okay, so M is 21.70 feet.
Is the M always going to be smaller than the E?
No. Not always. No. Depends on how, I guess, bulbous the curve would be, right? So yeah, bulbous. So if it's a real extreme curve, like over a 90-degree I, it's gonna the E will be smaller than the M. So a really good example of that would be a cul-de-sac. That's going to be the E is going to be much larger than the M in a cul-de-sac because it's over 90 degrees, right? So if it's still under 90 degrees, it'll be larger if your I is over 90 degrees. So think of it that way. All right, so let's look at finding the PC. So the PC equals what? PT minus L. Very good. All right, so what do we got there? So we have our PT they gave to us was 17 plus 50.00 minus L, which we found at 997.47. So the PC equals, actually, say it again. 7 plus 52.93. 53? 53. Okay. So PC is 7 plus 52.53. All right, so let's figure out our PI then. PI equals PC plus T here. So we figure out 7 plus 52.53 plus T, and T is 500. So our PI is 12 plus 52.53. All right, based on what I have shown you guys on these 3 example problems, you should be able to tackle problems 1 through 4 on that first homework page. Now, be mindful, it's not due next week, okay? It's not, won't probably be due the week after that, because there's a lot of problems in there yet that we have to tackle. So if you can get a jump start on it, great. But if you want to wait till the following week, which most of you probably will, because I'm telling you you can, that's probably what you'll do. So